Hello and welcome back to my YouTube channel. This is going to be the next devlog on my video game Glass Miners that I've been working on. As you can probably hear, I'm a little bit sick right now, but I still wanted to make a video because I actually made quite a lot of progress over the last few weeks, especially, and this is also what this video is going to be about, our internal dev tooling. So made quite a lot of progress on just, improving our workflow that we have internally. And just writing some simple but still cool tools that really help me in understanding what's going on in the game and also helping us basically create new content, especially in the future. So this is gonna be the video, just me basically showcasing what we have, what you might not get for free in your usual engine, but that works really well for us. Okay, so the first thing that I want to showcase is our cheat menu that we have. And so I've probably already shown this over the past few videos at some point, but basically what you can see is me just using this cheat wheel that we have. There's quite a lot of functionality that we have. So one of them would be, just getting random items that I would need, that I don't have to farm them. That's really the simplest one, but you can also see me enabling ghost mode and also invincibility mode, in which case I can basically walk anywhere I want. Like I can walk through walls, through lava, and the invincibility mode obviously just makes me take no damage. The other thing that you can see is this free camera mode. So you can see that I can basically move the camera anywhere I want. And these tools are obviously really simple and they're the most basic ones you could expect, but they're really, really helpful in everyday development because like when I just, try something, this makes me get there really quick. So the next tool I think is actually less common, and this is basically time modification. So what we can do in the game is we can actually slow down or speed up time depending on what we actually need. So I have those bound to two keys. So if I press F10, then time is going to slow down. If I press F12, time is going to speed up. And you can see that in action here. So this basically, just slows down the entire game. It's actually very simple to implement. The only small challenge here was that this is obviously a multiplayer game that is, has a dedicated server over the network. And so I basically have to synchronize this time modification across all clients and the server as well. So you can see that the server and the client use the same basic time modification here. And you might wonder, well, what is this actually useful for? So in this game, it's actually not that useful yet, but it does really help in figuring out, for example, the visuals, like the animations. But we're going to talk about that later. Okay, so this next tool is actually the newest one that I basically just finished implementing. I just call it the Entity HUD. It's basically, as you can see, just a bunch of text boxes that we can enable for different kinds of entities. So if I press tab once, then it will show me the information for all the living creatures that we have, because those are usually the interesting ones to actually look at. But I can also press tab again, and then I'll actually see the HUD for all entities. And so in this HUD, basically currently we only have really simple information. So we can see the ID of the entity. So that's the number after the pound symbol. We can see what kind of entity it is. We can see at which position it is. And if it's currently playing an animation, we can see some information about that animation as well. And so this is where the aforementioned time modification comes in handy, because I can basically play the game in slow motion and really just investigate what our animations are looking. And if we should maybe play around with the frame time, if we should add another frame in there, depending on how that actually looks. And so in the future, I definitely want to add more information to this entity HUD. So we could, for example, for different NPCs, it might be interesting to display some information like which state are they currently in, what kind of information are they looking at. So do they know where the player is, for example, whatever. So we can definitely extend this in the future, but for now, this is going to be a basic tool that really can help us give us some insight into our own state logic. So the next tool actually looks really cool. I really like that, although it hasn't really been all that useful over the past few weeks. So when I actually started working on sound effects for this game, this was actually really handy, and that's why it's still in there. This is basically our sound HUD. So what I can do is I can visualize which sounds are currently playing, and I can even visualize the kind of mixing history that we have. So these bars that you can see, those are wave diagram of the two channels that we actually output, and you can see which sound effects are currently playing. So you can see also how they are spatialized, how many channels there are in the source file, and how far along the actual sound effect we are. Okay, so next up is actually what I think is the coolest tool that we internally have, and that is the message history. So our game is obviously a network multiplayer game, which means that we need some communication between client and server, and we do that through messages. So a message is basically just some state that is synchronized between client or server. So either the client sends that to the server or the server to all clients. And so this message history panel we can use to basically see like what kind of information is currently shared between those. And this is it's a timed list, so you can see how long ago did this message arrive at the client or at the server. And we save basically the last 16 messages, I believe. But what we can do is we can actually pause this panel, so pause the recording basically, and then investigate the actual content of that message. All this content is actually printed basically programmatically, so there's no manual labor of basically having to print that out to the display. The language just allows us to look at all the members of a struct and basically see what's in there. And what we can now see is some information about the messages that we have received. So you can see, like, obviously there's a lot of entities moving around, which we can see. Those are the void eyes because they move I don't know, every half second or something, and there's multiple void eyes. And we can see the entity ID that I mentioned before here. We can see basically where it moved to and which direction it should point. We can also see on the right the messages that we send to the server. And for now, that's usually only the input messages. So basically what we are saying is, hey server, the player pressed these and these buttons, so please try to do something with that input. And this really allows us to dig into the network traffic that we have. So for one, we can actually like investigate how much traffic are we using, but it's also really helpful to just see like, oh, this message arrived or this message didn't arrive. And so that helps us figuring out why maybe the game isn't working it's supposed to work. Okay, so the next is going to be kind of standard again. I'm guessing that most of you have used a profiler before. But this is our built-in profiler into the game, so I can pop that up at any time, and I can basically see the last few frames and what took time in those frames. So I can see the history. I can basically select any of the past frames and then see like, okay, in that frame, which procedures actually took time. And then we also do some nice visualization based on colors so that I can quickly determine like, hey, what is actually going on here? And so what we can see, for example, that every so often this check for hot reloading takes a lot of time. This only happens in developer builds. So this is us checking the file system like, hey, did these source files change? Because if so, we want to hot reload them in the game. So that's us basically, that's another dev tool that we have. And so that takes a lot of time, but that's expected. And so what actually is surprising here is that applying gamepad vibration on Windows takes a lot of time. A lot more time than I had anticipated, so I'm going to investigate that actually in the future. But yeah, we can also investigate and see what is taking time in the main menu, for example. And so this is, again, pretty standard, but it is really, really helpful to have that built into the game itself. So again, I can just pop that up at any point. So if I'm feeling like, oh, the game is kind of running slow, then I can just press a button and I can see like what is taking time. And that's, again, really a really quick workflow that I really enjoy. Okay, so as the last and biggest point, I actually wanted to talk about the sprite packing again. So in the last devlog, I already showcased how I can add new textures to the game. I basically had to register some new enum members in the source code, and then I could add this sprite entry into the sprite pack file. That process was all right for individual sprites, but what we're relying on a lot are actually animations and then animation groups and whatever. Because, for example, if I'm just playing, then I also want to be able to say, hey, by the way, play just a walk animation on your guy that you're playing. And depending on which skin you have, that can be 3 different animations. And so I basically found out that, first of all, we've got a lot of sprites and they're only gonna grow. So I'm guessing we're gonna, have more than 1,000 sprites at some point. And we're also going to have a lot of animations, and it was a lot of duplicated work that you had to do. And I basically wanted to get rid of all of that. And so now we have a new sprite pack file, which is more complex, but also a lot more powerful. And that was actually quite fun to write. I don't want to go into too much detail here because I actually want to keep this video kind of short. But basically what we're doing is we're specifying all sprites and animations in the same file. We can basically infer based on the file content which sprites should be generated for an animation. So I can basically say, hey, here's this file called guy walk, for example. Take any layer that's in this file and generate an animation for that. And for each animation that you generate, basically look at all the frames that are in this layer. So we really just analyze a sprite file that we have, and we generate animations and sprites based on that. And so what that means is if our artist just wants to add a new animation, he only has to add a single line in the sprite pack file instead of the tens of lines that were needed before. And we can do the same thing with collections now. So collections are a new concept, which basically mean like, hey, this is one entity, or it could just be a skin. Basically, it's a skin, right? So we're collecting some animations that belong together semantically. So we've got a lot of animations for this guy 1, which is one skin. We've got a lot of animations for this frog. We could also in the future have multiple different versions of the frog, right, with this. And then we're going one step further even. So we've got this new sprite pack file, and what we're doing actually at compile time is the sprite index enum that I showed before, we're now actually generating at compile time. So we are looking at the sprite pack file while we're compiling the game. We're basically extracting all the information. So we're looking at, hey, which files are going to be opened, which sprites are going to be registered for this. And then we are generating this sprite index enum at compile time. And so you might wonder, why are we even doing that? Why not just use a string-based approach? There's 2 reasons for that. First of all, this is actually much quicker because in terms of runtime, because using an enum as an index is just a direct index, right? So based on that, I can actually calculate the position, like the UVs and the atlas, which I'm going to use for rendering, instead of first having to do like a hash table lookup, which is going to be very expensive. So this is much quicker. And this is also actually safer because if I'm just in the code, typing, hey, I want to draw some HUD texture for this. So for example, we've got a texture for hearts, right? For full hearts, for empty hearts. I can now actually at compile time check whether that sprite exists or not, or if I maybe mistyped something. Whereas with a string-based approach, you don't know that. So you would like just have a typo in there and you'd have to manually start the game, and then, go to the position where you want to be or to the state of the game where you want to be, and then check, hey, does this look correct? And only then do you actually know, like, yeah, this worked. And even worse, so if we decide to delete stuff in the future, we can't really be sure that the code isn't referencing that anymore. Because there might still be a string somewhere that says, hey, by the way, I need this sprite, but that was never really known. And like, yeah, you can kind of do a string in replace on that, but what if you're building a string at runtime? Because that could happen sometimes, and it does happen, for example, if you're iterating, right? You want to iterate over the 3 sprites that we have for this heart, for example, and then you're going to say, well, take heart underscore whatever, and then append the index to that. And that's a string-based operation. And that's not going to show up in your search and replace. But if you iterate over, like you take the base enum member, so heart underscore 0 as an enum member, and then you add 1 or 2 on top of that, if that enum member no longer exists, the compiler will complain. And it's not totally safe, obviously. Like if I only delete heart 2, for example, in this specific scenario, I might still have problems depending on how I write the code. But it's a lot more safe. A lot safer than with a string-based approach. And so that's basically why we're doing it that way still. But with this generation, that's actually really, really easy, really handy. And so I really like this new format that's going to speed things up in the future. Okay, so that was me basically showcasing some of the dev tools that we have. It's not all of them, but it's the most important ones. I hope you enjoyed the video. Maybe you even learned something new. If you have any questions, just feel free to reach out either here directly or on Discord, where I also post updates regularly, or you can just drop into the Twitch chat whenever I'm streaming and ask me some questions there. So again, thank you for watching, and I'll see you guys next time.